All right, we're going to look at a few examples here and how to use the calculator in order to calculate some of this stuff for us. It won't do all of it for us. So first scenario, suppose when we take a free throw in basketball, we average about 3 out of 10 successes. So for every 10 shots we make, or for every 10 shots we throw, we get the basket or make it about 3 times. What's the probability that it will take us 5 shots to get our first basket? Okay, we could do this by hand, but we're not going to here. So make sure you get your notes out to write down this keystroke process. We're going to go find geometric PDF, and that's going to be second under the vars key here. There's distributions. Right? We're talking about probability distributions. So no surprise they would be under distributions. There's a long list of them here, and the ones at the top are ones we're going to talk about later in the semester. If you scroll down, you have to go all the way to the bottom of the list. If you scroll up, it'll go automatically to the bottom. And see that's choice D and E are our geometric distribution options. D is geometric PDF. Okay, so select that one. We'll talk about CDF in just a moment. Geometric PDF, we've got to give it 2 pieces of information. We have to tell it P, what is the probability of success here, which is 3 out of 10. And you can actually put in 3 divided by 10, or you can put in 0.3, it doesn't matter. And then comma, which is right here. And then the number of successes you're asking about. What's the probability that it will take 5 was the question that I asked. So I'm going to put in 5. And that's all it needs. It just needs the probability. And then how many trials are you asking about? You can close parentheses if you want. You don't actually need to. And it will tell us there's about a 7% chance that it's going to take exactly 5 to get our first basket. So that's 0.07. Right, and I've got that written here for you. Geom PDF for geometric probability density function. You have to give it the probability and then how many trials you're asking about. Now, I alluded to this a few videos ago when we talked about the things we were going to be doing, that there's also the cumulative distribution function. And that's used to answer questions like this. What's the probability that it will take less than 8 shots or fewer than 8 shots in order to get our first basket? In other words, what's the probability that one of our first 7 shots will be successful? Now, the CDF always does less than or equal to. So we have to give it the probability and then the number, the same information as before, that we want to know the probability for less than or equal to. So if I want to know less than 8, that really means 7 or fewer. So we're going to put a 7 in there. Okay, you need to be conscious of the distinction between less than and less than or equal to, which is about a 4th grade distinction. So please don't tell me that you don't understand that. So geometric CDF here, cumulative distribution function, or cumulative, I guess it's distribution function. Same probability, 3 divided by 10, and then comma, we want to know less than or equal to 7. 91.8 if we round it off. So let's just say there's a 92% chance that we're going to get at least 1 basket within the first 7 shots, that our first basket will come before shot number 8. I think that seems pretty reasonable. 3 out of 10 isn't a lot, but we're given quite a few shots there, so there's a really good chance we'll get at least 1 of them. Okay, so that's how to use the PDF function and the CDF function. You could have found these by hand easily just by using the formulas, but the geometric PDF and CDF probably a little bit quicker. Now let's look at our range of likely outcomes. Our mean is going to be 1 over our probability. So that's going to be 10 divided by 3 instead of 3 divided by 10. So that's going to be, just round it off to 3.3. We don't need to be too specific here. We're talking about whole numbers after all in the end. And then our standard deviation is going to be the square root of the mean. So the square root of 3.3 times 1 less than the square root. I apologize for the yuckiness of my calculator here, but we're doing the square root of 3.33 times that same number 3.33 minus 1, or 2.33. That gives us 2.78. I'm just going to go ahead and put 2.8 there. So to do the range of likely outcomes, we would do 3.33 minus twice the standard deviation, which is going to end up being negative. And it's always going to be the case when we're talking about the geometric distribution. The range of likely outcomes is always going to be from a negative number, so round that off to 0, up to a positive number. And here's a neat calculator trick. If you do second enter, it brings back the stuff you just typed in. So if all you need to change is a minus sign to a plus sign, and I apologize for the ugliness of my calculator, I've got a dead column of pixels there. So it happens to be right where the plus sign is, so you can't see it. But I did change that to a plus. That'd be up to 8.89, which we would round down to 8. So our range of likely outcomes is 0 to 8, which means that there's a 95% chance that it should take us between 0 and 8 shots to get to our first basket. So let's check that. Second vars to get to our distributions, geometric CDF. And I'm going to put in my, 0.3, comma 8. So what's the probability that it will take no more than 8 shots, or between 0 and 8, and we get 94.2%, which is awful close to 95, so that makes sense. All right, let's look at another one. Having a baby, the probability of a particular defect is 0.1. The defect I always talk about is having red hair because it irritates my wife, who's a redhead. What's a probability that the first defect will occur on the first try? So this particular couple has a 10% chance with each baby of having a red-headed baby. What's the probability that their first one will be a redhead? Well, that's a specific one, so we're going to use geometric PDF. There's a 0.1 chance. What's the probability it will occur on the first baby? Now, if you've been paying attention and thinking back, the probability that is going to occur on the first one is always just going to be P. So we really ought to get 0.1 for our answer there, and we do. So there's a 0.1, or about a 10% chance that the first baby is going to be a redhead. What's the probability that the first redhead will be the third baby? Well, same thing. So I can do second enter and get my stuff back here. What's the probability? 0.1 for the probability, and then 3, because we want to know the probability the first one will be on the third baby. That's about an 8.1 chance. 8.1% chance. 0.081 is 8.1%. And the last question, we'll end this here because we're over time. What's the probability we'll have 5 of them with no defect? Well, for this one, let's look at the probability CDF. The CDF with this probability, what's the probability the first defect would occur within the first 5? So if you find the probability that the first one will occur within the first 5, there's a 40.9% chance. Let's round that up to 41, that they will have a red-headed baby within the first 5. If we subtract that from 100, we get a 59% chance that they won't have a redhead within the first 5, which makes sense. 10% is a fairly low risk, especially if you're talking about a defect that has no negative consequences. So the probability you make it through to 5 kids should be fairly high. I think we'll do another one of these with a couple more examples.